Okay. Greetings, Algebraniacs. Yes, I'm sure you hate that. Oh well. So I am here again teaching you your next lesson while I'm gone. And you know I can't start out if I'm not going to start out the right way with your jokes. So, I saw a sign. I was trying to park downtown the other day and I saw a sign that said this spot for frogs only. All others will be towed. Come on, that was pretty good. This parking spot for frogs only, all others will be towed. Please explain that to Aldo if you'd be so kind. Great. So, our next unit that we're heading into is chapter 6. I would suggest strongly that you get your iPads out, open up your books, because I'm videotaping this on Sunday on View FLA Day. I'm doing this by myself, so I won't be able to zoom in and out. I don't know how well you're going to be able to read what's on the board, but I needed to get it back far enough where you could see, yet not be too close to where you're going to miss some things. So I might come in a little closer as I'm thinking about it. So again, it's chapter 6, unit 6.1, page 292. And this next unit is dealing with exponents. I think in general, you're going to find this unit to be pretty easy, or at least easier than what we just got done with systems of equations. Working with exponents, it's just a matter of following the rules. Like at the beginning of the first semester, the only thing that makes them somewhat tricky is going to be either negatives or fractions, but they're not that tricky, especially if you just remember the rules, okay? So that's the start of this chapter, is going over the rules of exponents. The first thing, just a general first reminder. I need to back it up. I've gone too close. Bear with me just a second. I need to have a little spot where I can write. I'll write big though, so at least you can see it. So, exponents again involve having a number raised to a superscript, they call it, raised to an exponent. So I've written 3 raised to 2. We call this 3 squared. Think about what that means. You should have a piece of paper out, by the way, because you're going to work through some examples like always as we get through here that you'll turn in for bell work. So please get a piece of paper out and start working these things through. What does 3 squared mean? It means 3 times 3. It means 2 3s times each other, which of course equals 9. What it doesn't mean, and some of you make this mistake, it does not mean 3 times 2, which equals 6. That is not what 3 squared means. It means 3 times 3. Okay? If I had 3 raised to the power of 3, what we call 3 cubed, that means 3 3s, all times by each other. 3 times 3 times 3. What does that equal? I heard you. 27 is the right answer. 3 cubed is 27. Okay? And again, it does not mean 3 times 3, because that's 9. It means 3 times 3 times 3. Last one to hit this off. Raised to the 4th power, we call that 3 quadrupled. Okay? And that is just 4 3s multiplied by each other. 3 times 3 times 3 times 3, that equals 81. Okay? So that's your general introduction to exponents. More of a reminder, because I'm confident you all have seen this before on many times. You're going to see exponents moving forward in all kinds of things. From here on forward for the rest of your math, there will be tons of exponents. We deal with it in geometry with Pythagorean's theorem, for example. For calculating area of a circle with pi r squared, and of course Algebra 2 uses it extensively. So just get comfortable with exponents. They shouldn't trip you up. You just need to remember the rules. So in this first core concept in your book, again page 292, for the 0 exponent, the first rule you should remember: any non-zero number raised to the 0 power equals 1, no matter what it is. They give an example here: 4 to the 0 equals 1. Negative 1 to the 0 equals 1. 1 million to the 0 power equals 1. Negative 3/4 to the 0 power, all of it equals 1. The only thing raised to the 0 power that is the odd is 0 raised to the 0 power. And you see that right here in the core concept. That is undefined. It's like dividing by 0, which is also undefined. 0 to the 0 power is undefined. It is not 1. Every other number raised to the 0 power is 1. All right, I'm going to slide up the screen just a little bit. Negative exponents. The next rule you need to recall. It shows here in the book 4 to the negative 2. 4 to the negative 2 power. All you do with that is put it in the denominator and the 2 becomes positive. Okay? So 4 to the negative 2, rewrite it as 1 over 4 squared. And recall that means 1/4 times 1/4, which equals 1/16. If you know that 4 squared is 16, then 4 to the negative 2 is 1/16. Just the inverse of that answer. Okay? That's the negative exponent. All right, so here's an example. I'll roll up again. Evaluate each expression. First, letter A says 6.7 to the 0 power. Very simple. Always simple. That equals 1. Anything aside from 0 raised to the 0 power equals 1. B says negative 2 raised to the negative 4. Oh, how joyous. They threw all kinds of negatives in there. Not a big deal. You would rewrite this as 1 over negative 2 to the 4th power. Please see what happened. Only the negative of the exponent went away. The number itself stays negative. It's just the exponent that changes. Then you have negative 2 to the 4th. Well, it's actually negative 1/2 to the 4th, but we'll look just at the negative 2 to the 4th. Negative 2 to the 4th looks like this. Negative 2 times negative 2 times negative 2 times negative 2. First of all, if it's raised to an even exponent, a negative number raised to an even exponent is always going to be what? Any negative number raised to any even exponent will always be positive. Okay? It will always be positive. Any negative number raised to an odd power will always be negative. You must remember that. Okay? So we have negative 2 times negative 2 times negative 2 times negative 2. We know that it's raised to the 4th power, so it's going to be positive, so ignore the negatives. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So negative 2 to the 4th power is 16, which makes my answer here 1 over 16. Okay? Negative 2 to the negative 4th power is 1/16. All right, great. Example 2, let me erase this. Now they want to make your life a little complicated, of course. It wouldn't be math books if we didn't make things complicated in your lives. It says 4x to the 0 over y to the negative 3. 4x to the 0 over y to the negative 3. Okay? X to the 0. And it does tell you that x is not 0. So, x to the 0 is 1. So you can rewrite this top part just with the 4, because 4 times 1 is 4. 4 over y to the negative 3. The same thing applies when the negative exponent is in the denominator as it did when it was in the numerator, is you flip it to the opposite side. So the y to the negative 3 is the denominator. When we bring it up to the numerator, it becomes positive, so you rewrite this as your final answer of 4y cubed. Okay? 4y cubed. So again, I just did it methodically. I changed the x to the 0 first, rewrote that, then flipped the y negative 3 up to the top, and it became y cubed, 4y cubed. All right, here's your chance to demonstrate your work. Please use that paper that I asked you to get out. You have got, I believe it's 3 at the bottom here. Oh, there's 4. Wonderful. 4 at the bottom of page 292. If you can't see it here, use your book. I'm going to step aside, give you a minute. Teacher, please pause here and let them get these work done. Okay, let's evaluate them. Number 1 says negative 9 to the 0 power. Negative 9 to the 0 power. Again, anything to the 0 power is 1. Okay? Number 2, 3 to the negative 3rd power. Your first step is put it in the denominator because it's a negative exponent. So it's 1 over 3 cubed. So then you just cube 3. 3 times 3 times 3, which we just did a moment ago. This equals 1 over 27. Number 3, negative 5 to the 0 over 2 to the negative 2. Again, it's the negative numbers that make this somewhat complicated. Take it step by step. I do the top one first. Any number to the 0 power, any number, negative or positive, is 1. So I'm going to rewrite this as 1 over 2 to the negative 2. Then because in the denominator we have a negative exponent, we bring it up to the numerator, which makes it positive. I have 2 squared, which equals 4. I didn't bring the 1 is already up here. It's 1 times 2 squared, which I didn't write, but it's 2 squared. The answer is 4. All right, I'm going to erase for the last one because I want to keep my writing up high. 3 to the negative 2 over x to the negative 5, or times x to the negative 5 over y to the 0. Okay, so I'll write it up here. 3 to the negative 2 times x to the negative 5 over y to the 0. I hope you quickly know by now y to the 0 is 1, so that just goes away. Okay, y to the 0 disappears. I'm left with 3 to the negative 2 times x to the negative 5. I just now bring those down into the denominator to get rid of the negative exponents. So I have 1 over 3 squared times x to the 5th. The last thing, if you can simplify, you should. I can here. 3 squared, you all know, I'm sure by now, that's a 9. So the answer final is 1 over 9 times x to the 5th. 1 over 9 times x to the 5th. All right. Going to the next page. 293. Three rules now, 3 more rules. So again, we have the first rule, any number raised to the 0 power is 1. The second rule, any power raised to a negative number, you put it on the opposite side of the fraction, whatever it's on. Okay? Third rule is called the product of powers property. That's p cubed, powers of product property. All right? What that tells you is if you've got 2 numbers with the same base only, the same base, here it's 4 to the 6th times 4 to the 3rd. The number 4 is your base number. To apply this power, the base has to be the same. So we have 4 to the 6th times 4 to the 3rd. The rule is you can take those 2 exponents and add them and put that number together over the 4. So 4 to the 6th times 4 to the 3rd, you rewrite it as 4 raised to the 6 plus 3. Add the 6 and the 3 together, you get 4 to the 9th. Okay? It shows algebraically what that looks like. A to the m times a to the n equals a to the m plus n. Just emphasizing what I said. If this was 4 to the 6th times 5 to the 3rd, you cannot combine those. This does not become 4 times 5 is 20 raised to 6 plus 3 to the 9th. No, 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 no. I said no. No, 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 no. It's a good 80s rock song. All right. You cannot do anything with this except multiply them out and then multiply them together. But there is no shortcut. the base number, the 4 and the 5, must be identical to add the exponents. All right, next rule, quotient of powers property. So if you have the same base number divided by another base with an exponent, you can rewrite it with the base number and subtract the bottom from the top. So the example they give here is 4 to the 6th divided by 4 cubed. They rewrite it as 4 raised to the 6 minus 3 button, which is 4 to the 3rd. Why I said the word button there, I have no idea. But raised to the 3rd power. Great. All right, and then the algebraic expression looks like this. A to the m over a to the n is rewritten as a to the m minus n. Okay? Last one here, power of a power property. This means you've got a number, a base, raised to an exponent, and then that whole term is raised to another exponent. So we have 4 to the 6th cubed. This rule states that you can take the one exponent, times it by the other exponent, and rewrite it. That becomes 4 to the 18th power. Because 6 times 3 is 18. Okay? Let's look at some examples to reinforce this. The first example says 3 squared times 3 to the 6th. We have the same base. The base here is 3. So we have 3 squared times 3 to the 6th. Because our base is the same, I can add those exponents. 2 plus 6, it becomes 3 to the 8th, which they give you here is 6,561. Okay? I'm not going to expect you to have this kind of thing memorized. And in fact, with these kind of big ones, I will allow you to use your calculator. You do have a function on your calculator that helps this. It's this function. It's y to the x. So in this case, you put in the number 3 in your calculator, push the y to the x button, then put in the 8 number, and you'll get this number. I'll pause here, take my word for it, use your calculator to confirm how to use the y to the x function. Okay, next example, letter B. Negative 4 squared over negative 4 to the 7th. Negative 4 squared over negative 4 to the 7th, I can rewrite that as negative 4 to the 2 minus 7. The top minus the bottom exponent. Negative 4 to the 2 minus the 7, which we then rewrite as negative 4, 2 minus 7, you all should know is negative 5. I have 4 to the negative 5th. You're not done. I have a negative exponent, so I need to rewrite that. Remember what we just learned. You drop that to the denominator. It's 1 over 4 to the 5th power, which comes out to be 1 over 1,024. That is your final answer. Last example, letter C. Z to the 4th to the negative 3rd. Okay? You can do this 2 different ways. Either one is fine. You will arrive at the same answer either way you do it. I could first, because I have a negative exponent, write this and put it in the denominator so it looks like 1 over z to the 4th to the 3rd. And then by our powers of power property, I multiply the 2 exponents. 4 times 3 gives me 1 over z to the 12th. That's one way to do it, or you can come here first and you can multiply the 2 together, because I have z to the 4th raised to the negative 3. So 4 times negative 3 gives me z to the negative 12. And then because it's a negative exponent, I drop that down to the denominator. I have 1 over z to the 12th. Please notice, either way you approached it, you arrive at the same answer. It doesn't matter, whichever way you like. Okay? Back to your paper. 6 examples on the bottom of page 293. All right, work out these 6 examples. Please work them together. Get into the groups like I've been having you do. You should already be in them. I didn't say that for the first time. I'm saying it now. Please get into your groups and work through these. And then come back. Teacher, pause at this time, please. All right. So number 5, I have 10 to the 4th times 10 to the 6th, or negative 6, sorry, 10 to the 4th times 10 to the negative 6. So what I need to do, you can do one of two things. I'm going to add them together first, because I have the same base being multiplied with exponents, so I can add my exponents. So this becomes 10 to the 4 plus negative 6, which I then rewrite as 10 to the negative 2, which I put now on the denominator because the exponent's negative, so I will have 1 over 10 squared. You all definitely should know, I expect you to have it memorized, it's not a hard one. 10 squared is 100. So the answer to number 5 is 1 over 100. Number 6, x to the 9th times x to the negative 9th. Okay, again, I'm going to add them together first. X to the 9th times, well, I'll just write x to the 9th plus negative 9. 9 plus negative 9 is 0. X to the 0 equals 1. Answer for number 6 is 1. All right, number 7. Negative 5 to the 8th over negative 5 to the 4th. Please don't let these negatives fool you. They don't matter in terms of flipping anything. It's just a negative 5. Our exponents, because it's being divided, you can subtract these exponents. Which means I have negative 5 to the 8 minus 4 power, which is negative 5 to the 4th, which equals, pardon me while I do this in my head, 5 times 5 is 25, 25 times 5 is 125, times 5 is 625. Remember, a negative number is being raised to an even power, so the answer is going to be, that's right, positive 625. All right. 8, I have y to the 6th over y to the 7th. Okay, I have two bases in a denominator with exponents, so I subtract. This becomes y to the 6 minus 7, which is y to the negative 1. And because it's a negative exponent, it drops to the denominator. My final answer is 1 over y. Because y to the first you just write as y. Number 8. 6 to the negative 2 to the negative 1. This looks ugly, and you're going to hopefully have seen how easy it actually is. Because one exponent is being raised to the other, I can multiply them together. So I have 6 raised to the negative 2 times negative 1. Negative 2 times negative 1, as you all know, becomes positive 2. Negative times a negative is a positive. So this becomes 6 squared. Another number you must know, 36. No calculator for that kind of a square. You should know all of your squares for sure up to 12. Higher would be better, but certainly up to 12. You need to have those memorized. 10, w to the 12th raised to the 5th. W to the 12 times 5 equals w to the 60th. W to the 60th power. That's it. There's your examples. I think that's all I'm going to put you through. Let me see. Is there one more thing? Oh, maybe there is. Oh, okay. Pretty straightforward. It's the power of a product property. Okay? So they have this first one. Again, this is on page, I believe, 294 now. They have this first one. 3 times 2 in brackets to the 5th power. You could rewrite that as 3 to the 5th times 2 to the 5th. Okay? So know that you can factor this out to where you rewrite it as 3 to the 5th times 2 to the 5th. Now some of you may ask why, because what you probably want to do instead, which you could, is rewrite this as 5 to the 5th power. I'm sorry, 5. 3 times 2 is 6. Try that again. Okay. You could rewrite that. 3 times 2 is 6 to the 5th power. But the reason I want you to know about factoring it out is because there are times where if you factor it out like that, you may have another number in the denominator that is 3 to something that you can reduce. You'll see reasons why that is. Trust me, there's some times where you want to do that. So just know that's the case. And then the bottom one, the power of a quotient property, is essentially the same thing with division. 3 over 2 to the 5th power can be rewritten as 3 to the 5th over 2 to the 5th. Same thing. Okay? 3 halves to the 5th power can be rewritten as 3 to the 5th over 2 to the 5th. Right now I plead the 5th. All right. Let's see what examples they give. A is negative 1.5y bracketed squared. So you can rewrite that as negative 1.5 squared times y squared, which becomes negative 1.5 squared will be a positive number because it's an even exponent, 2.25 y squared. Okay? B says, in brackets, a over negative 10 cubed. You can rewrite that as a cubed over negative 10 cubed, which is a cubed over negative 1,000. Okay, again, negative number raised to an odd exponent makes it a negative number still. Letter C says 3d over 2 bracketed to the 4th power. Okay, which we can rewrite as, how do they do it? They did a double split. They first did 3d bracketed to the 4th power over 2 to the 4th power. Then they split that top apart to 3 to the 4th over d to the 4th times d to the 4th over, I'm going to multiply this out, 2 to the 4th is 16. And then finish off with 3 to the 4th is 81, d to the 4th over 16. This is reduced, they do not have a common factor. 81 over 16 raised to the 4th power. Okay, last one's kind of fun, if you like this kind of thing, which I do, otherwise I wouldn't be here. 2 to the 2x over 3 bracketed raised to the negative 5th power. Before I even split these up, what the easy thing for you to do in this situation, if this whole thing is raised to the negative 5th power, just flip the fraction completely over and make the exponent positive. So I'm going to rewrite that. It becomes 3 over 2 to the x to the 5th power. Then I split that up. I have 3 to the 5th over 2x to the 5th power. Now again, I need to split this up. 3 to the 5th first is 243. 243? See, 9, 27, 81, yeah. 243 on top over 2 to the 5th times x to the 5th becomes 243 over 2 to the 5th is 32, x to the 5th. And now I can actually reduce this. These are both divisible by 3. Do you know how I know that? Actually, I'm wrong. Ignore me. Great. Never mind. This is done. 243 over 32x to the 5th. Just testing you. All right. The last stuff to work on your paper to be turned in. At the bottom of this page. 11 through 14. Okay, 11 through 14. Teacher, at this time, please pause. Kids, work together again in your groups. Complete these and we'll come back. Okay, so we're back. Number 11, 10y bracketed to the negative 3. The first thing you're going to do, I would put it over like this. Because of the negative exponent, put it 1 over the 10y cubed. Split them apart. 1 over 10 cubed times y cubed, and then just simplify. 10 cubed is 1,000 y cubed. So 1 over 1,000 y cubed. (12) Bracketed, -4 over n raised to the 5th power. So we're going to split it. -4 to the 5th power over n to the 5th power. Okay? -4 to the 5th. There's a fun number. Let's see. 1664. I actually may have to do this multiplication, dadgummit, on my calculator. I hate that. Give me a second. -4 to the 5th power. Y to the x to the 5th. Got it. -1,024. I'm sure you guys knew that long ago. It is a negative number because it's a negative base being raised to an odd exponent. So it's a negative number, -1,024 over n to the 5th. Okay? 13. 1 over 2k squared bracketed to the 5th power. Not terrible, a little tricky, we'll be fine. We're going to split first the top and the bottom. So the top I have 1 to the 5th. I'm just going to leave that as 1 because 1 to any power is 1. As long as it's a positive exponent, I should have said. 1 to the 5th power is just 1. Then I have 2k squared bracketed to the 5th power. Now I split these terms apart. I have 1 over 2 to the 5th times k squared to the 5th. Oh boy, aren't they having fun with us? I love it. 1 over 2 to the 5th is 32. K squared to the 5th power, I'm raising one exponent to the other. Our rule of power to the power property is you multiply the exponents together. 2 times 5 is 10. This is 32k to the 10th power. 1 over 32k to the 10th power. That was an awesome one. Love it. I'm sure you all hated it. Oh well. All right. Last one. 14. 6c over 7 to the -2 bracketed. I'm going to flip-flop them and rewrite it as 7 over 6c squared. Then I split it 7 squared over 6c squared with brackets. This becomes 49 over 6 squared times c squared, which becomes 49 over 36 c squared. That is your answer. 49 over 36 c squared. Pretty simple rule. The only thing about exponents is just know the rules. The math is not hard. It's just knowing the rules. I am pretty confident that is it. Let me double check. That is, I don't want to worry about this stuff over here. Okay? So, what you have then is your homework. Homework is on page 296. We're going to go 5 through 31 odd. I do want to get a word problem in there. Ooh. Actually, then we're going to jump to 37 through 43 odd, and 45 will be the one word problem I want you to work through. All right? So it is again 5 through 31 odd, jump to 37 through 45 odd. And I'll put that both on Schoology and Big Ideas. That is your homework that is due by Friday. On Friday you'll have a worksheet. So that covers exponents. You got this homework due Friday that I'll be looking for. You're not allowed to turn it in late. You can, you'll get no credit for it. It will be due by end of the day Friday. You'll have a worksheet as well I'll be giving to you on Friday to practice through, being prepared for what will be a quiz when I see you next on exponents. Okay, I will review them. Again, there's no class Monday, it's President's Day, so my Tuesday classes will have a quiz, and then my other class has their quiz on Wednesday. We'll review first, okay? Have a great time. Missed you guys. See you soon.